was in at my local electronics supplier and I saw this thing sitting there and I thought it was cheap. I mean, this was like $20. I thought, you know, this would be perfect for a teardown video. We'll see how it looks and we'll take it apart and just see the build quality of this thing. And what this is this is a video camera. It is not high definition. It's a standard definition NTSC camera, but it is disguised like a sprinkler. I've yet to open this thing up yet, other than in the store I opened the box up. So this is the first time I've actually seen the camera itself. I haven't hooked it up or anything yet, but as you can see, it looks like a very realistic sprinkler. Now, of course, someone touches it, they're going to know it's not real because it's not metal, it's plastic. But even complete with what looks like the little glass ampule that bursts and turns on the sprinklers. The camera lens is actually right in the center. There's the lens there. So a camera like this mounted on a ceiling would look straight down and give you a bird's eye view straight down into a room. And to tell you the truth, nobody would ever know that that's a camera from a distance unless you actually got up and looked at it. Even if it was placed up on a wall, right? The wires are concealed. You don't know that that's a camera sitting there unless you get up close to it. If it's up at the ceiling, you're not going to think that's a camera. You're going to think that's a sprinkler. Especially if it's mounted in this orientation up on a ceiling. So I figure what we'll do is we're going to hook this thing up. We're going to see what type of picture this thing produces. Now it just needs 12 volts, so I just have to dig up a 12 volt adapter, which shouldn't be an issue around here considering the number of 12 volt adapters I have. And I'm just going to feed the output of it into my my Wavecom modulator that I repaired last week, and I'll just send it out on channel 2 over to my TV and we'll take a look at how the picture looks. Okay, I've got my video cable with my adapter. We'll just plug it into the camera there and plug in power, and we have a picture on the monitor. Now, my adapter here is kind of a bit bunged. Let's just clean that up a little bit. Now, at first look at this picture, it is a grainy picture. I mean, I guess for what it costs, I was expecting a little bit more. I'm putting it purposely on this plasma monitor because this plasma monitor is not a high definition monitor, it's standard definition. I'm just going to actually grab one of my other cameras that's also a standard definition camera just so I can do an A/B comparison just to see what the difference in the pictures. But this looks to be really quite low. If we look at the telephone cable in the background, look at the aliasing as I rotate the camera. I'm sure that shows up. And what I'm going to do to make a fair comparison is I'm actually going to do a direct recording off this camera onto my DV deck so that we can actually see the actual quality of this thing without just being captured from the screen. I'm just looking at it for evaluation off the screen here. It looks pretty grainy at this. Now, to make sure that that graininess was not being added by modulating it onto channel 2 and then sending it through the tuner and stuff in the TV, I've now plugged the camera directly into the video input. If you notice, like, even there's no detail in the shingles on the neighbor's roof. I mean, it really looks pretty raw. Let me grab another camera, and this is not an expensive camera, but it was part of my old security system before I upgraded to high definition. Let me grab one of the cameras from that setup so that I can do an A/B comparison. Okay, well, maybe it doesn't look so bad, because this one actually looks worse. This one, there's actually no detail whatsoever. The neighbor's house is completely washed out. Like there's no detail whatsoever. Even when I bring it into the shop here, this camera has actually suffered some burn-in. You can see an outline from where it was sitting. You can actually see some shading from the color filter that's been burned from it sitting on the same image for years. But even if I look at that, that hose there, it doesn't look that clear. Again, I think it should look a lot better on this plasma, just because it's not a high definition plasma. It's a standard definition, so this should be displaying. I know it's hard to tell with the camera shooting it, because using this high resolution camera here, it tends to strobe. You can see, maybe if I defocus it a bit, but you can actually see the pixels on the screen. That's the problem when you use a 4K camera. Even when shooting in high definition, you're still using the full 4K chip, and it tends to show aliasing up when it's downscaled to high definition when you're shooting a digital screen. But just looking at this monitor, this picture is not really any better. It's as bad. I'm going to try another one of these cameras from the same batch and see if it's just this one that's causing this picture to look like this. So here's a third camera, and again, this one actually looks a bit better, but there's still no detail. You can't see any detail in the neighbor's roof. If I show you the same shot from my production camera here, we'll take a look at the difference. So basically, that's the shot that I'm shooting, and that's how it should look. That's a good camera there. And these other little standard definition ones, well, they're not showing any of the detail. We'll go back to looking at the camera again that I'm holding here, which has got roughly the same shot as this, just shooting it off the screen. But you see, there's no detail. There's no detail at all in the roof line here. But again, that's just the resolution. But if we look at we can see the cable, the telephone cable going up the street. It really quite badly aliases when I rotate the camera. But that's not what the object of this video is. The object of this video is to look at that camera that's disguised as a sprinkler head. We'll take a look at the video from that, and then we're going to tear it apart and take a look at the camera itself that's inside it. Okay, now looking at it, yeah, I guess it is about the same, maybe a little bit better. I can see a little more detail here on this camera than I could on the other ones, which were QC brand, but they're also 5 years old. This one here is supposed to be a Sony chip on this thing, but it is only standard definition, so you're not going to be reading license plates from across the street with this, that's for sure. Let's get a close look at the camera itself. So I've just kind of, as you can see, temporarily attached the unit, and I'm going to make a recording. So now I'm making a recording, and this is how the unit would be if it was mounted to the ceiling. This is the type of picture you'd get. You'd get a shot of someone walking in, and unless they actually looked up at the camera, it's actually kind of useless because it has a very narrow field of view, as you can see. It doesn't have much of a great field of view, just looking straight down. So as a security device, unless it's on a very high ceiling, this is on a 9-foot ceiling here. Actually, no, this is on a 10-foot ceiling. You're not going to see much because it doesn't have a great field of view. Maybe if we're looking at a straight down shot on a workbench or something, it would be adequate. But again, it's only standard definition. But I just wanted you guys to see what the unit looks like. And I've been recording some shots on my DV deck here, which I'll punch in here so you can see what the difference of the picture quality looks like. Popping off the bottom cover, or the top cover I should say, reveals that the camera circuitry is all contained in this top cover. And what we're going to find is that the sensor is just on a separate board by itself. There's a small, flat, flexible ribbon cable that connects the sensor to the rest of the circuitry, which would make this the ultimate camera for, you know, for remote mounting, where you could mount the camera circuitry out of the way and just have a small pinhole for the lens to pop through and photograph. So let's take off the sensor here and take a look at that. So removing the circuit board reveals that there is enough slack here that I can open up this ribbon cable connector and remove the ribbon cable. So just the little tab just flips up, and now the CCD, or the CMOS I guess, I think it's a CMOS camera. This might be a CCD though. I bet you this is a CCD because look at all the support components. Yeah, this will definitely be a CCD camera, because a CMOS camera, they would have your system would be on the chip. So this is going to be a CCD sensor here. This is the circuitry for this thing. It's a 1/4 inch Sony CCD. You see it says right here it's a Sony. So now I just have to figure out a way to get to the rest of the unit down so that I can. There we go. We just kind of pop these little tabs out. I was wondering how the thing was put together, but now I realize it's modular, and this should pop out just like that. And now I can get at the actual screws, because the housing here was preventing me from getting at the screws. So now I can get at the screws and remove the screws. I'll just widen that camera up a bit so you can see what's going on a bit better. And then we'll remove the actual 2 screws here that hold in the actual camera board itself, so we can take a look at the CCD and the lens. And here's our lens. So here's our CCD and our pinhole lens for the camera. Now as you can see, it's a true pinhole lens. Now we have a camera that can be mounted virtually anywhere. And there's lots of applications that can be mounted into and provide a real stealth image that could be built into any number of things. I have a clock in mind, the one that I built out before. I'm thinking maybe I'll change it to this camera here, because I think this one probably will operate a little better in low light. Maybe not though, because it is a very small lens, but I'm thinking this probably will operate a little bit better in low light than the other one. But let's connect it up to the board so that we can take a look at the picture off of the unit itself. So there's the camera attached to its control board. Let's turn it on and take a look at the picture. And there once again is the picture. I'm just going to dim the lights down in here, and then I'm going to turn out all the lights in here with the exception of there's one 13-watt fluorescent now running, and there's the actual monitors. Going to turn out that last light, and now the only light that's on in here is the actual light coming from the TVs. And as you can see, well, I'm getting a bit of, it's picking up a bit of light from the TV itself. Of course, as soon as the TV comes up with a brighter picture, it's gonna brighten up. But in almost total darkness, well, it's almost totally useless. That is noise from me just touching that flex cable. So I think this is where this camera suffers a bit. You get a bit of noise because it's got that cable to transport the signals from the imager to the processing board. But I still think this camera would be good as a project camera to build into something where you needed a small space, or you only had a small space to put a camera. It would probably still get the job done. And for 20 bucks, it probably is not such a bad deal. There's a few pixels, as you can see here. There's a couple pixels that are stuck. You can see it down in the bottom corner there. And it's not it's not a really good high resolution picture. I'll just turn on one little light. I've just got my little desk lamp on now, and as you can see, just this little desk lamp provides more than enough light. So for a low light room, you could monitor in low light, but you couldn't monitor in total darkness. But yeah, I think this one might be a winner. If you can find these things cheap like this, as I say, I bought this at a clearance place. I think it was 20 bucks, something like that. They had a whole box for them down at the electronics supplier. They had another one that was same camera, but it was in a smoke detector. But there you go. That's a teardown of this little Sony made CCD camera. Now I get to put this thing back together, and at some point I'll figure out something to do with it. There you go, it's back together and it's working, and until I find something to do with it, I'm going to put it back in the box. But at some point this camera is going to find its way into our project.